Hey everyone, welcome back to another day of Advent of Code 2023. Today we're looking at day 12. Now day 12 is an interesting one. I only got one gold star for this problem, but nonetheless, I think it's interesting to have a look at, in this case, my failed attempt. So I was traveling at the time. I told myself, look, it's best to move on to other days, and I'll come back to this if I finish all the other puzzles. Inevitably, I never did, but there's probably still some interesting stuff here. Anyway, the code's in the repository in the description. If you're enjoying these videos or anything else, leave a comment, subscribe, do all that YouTube stuff. But otherwise, let's get stuck straight into it. Alrighty, so for today's puzzle, this is a sample of the input file. It is missing one component, which we'll see next, but each of the lines, it has a pattern, and then it has some numbers after it. These numbers represent the length of each group of hash characters to the left. So the top line, 113, has one hash, followed by at least one empty space, which is represented by a dot here. Another hash, empty space, 3 hashes, and so on. Now the actual input file looks a little bit more like this, and it has the introduction of a new third character that may be present, which is a question mark. A question mark is an unknown character, and it may be a space or a full stop representing an empty spot. Our job is to determine how many valid solutions there are given the, let's call it a checksum at the end of the line. So knowing that we need 113 as the final resolving pattern, how many valid combinations of full stops and hashes can fill out the question marks in that line and still give us the answer that we want. So looking at an example of processing just one line, this one here has all question marks except for 3 hashes, and it has the checksum of 3, 2, 1. Below it, you can see every valid solution. Now we can rule out the very first question mark as a hash because we know that the length of the first group must be 3. If there was a hash there, it would be at least 4 long, so we know that must be a full stop. Likewise, we know the second question mark that is, must be a hash, full stop too. But there's a lot of different combinations with those that are left, and you can see them all below. In total here, there are 10 valid solutions for this one line. If we went through this process for every line in the input file, summed those all up, that is the desired final answer for this puzzle. So let's have a look at the way that I attempted this first. Then we can look at the ideas that would have made part 2 possible. The solution here does correctly work for part 1, and it's not a bad solution for part 1, but it's one of those cases where part 2 adds a level of computational complexity. That means that this solution in particular is never going to reach an answer in a reasonable amount of time. The current, master branch in the GitHub repo below is my attempt at the ideal solution, which uses dynamic programming. But if you jump back a few in the history, you'll see the solution we're talking about today. So getting into it, looking again at this single line, we know that each question mark could either be a dot or a hash. And we also know that there are rules about the number of hashes and the spaces between them. So the question I had first was, how can we quickly validate if any given solution to this combo of question marks or full stops and hashes is valid? Putting that another way, if we look at this checksum, we say, all right, we know this defines the rules of the checksum. And in this case, I decided to use regexes to validate whether a given string matched the input checksum of, say, 3, 2, 1 in this case. The way we did that is we said, all right, we've got a few different components that exist within our answer. We've got maybe some dots. Now I use the escape character here so that it's not any character as a dot. We say that's 0 or more dots, exactly 3 hashes, followed by at least 1 dot, but maybe more, then 2 hashes, then at least 1 dot, maybe more, 1 hash, and then maybe some dots afterwards. And that put all together, as you can see down below, is a regex that would validate the checksum string of 3, 2, 1, assuming we've resolved all our question marks into dots and hashes. Now this opens the question of how do we include question marks in the regex that we're looking at, and I'll show you how we did. So rather than just look for a dot character, in either case we look for a set, which is either a dot or a question mark, or a hash and a question mark n times. Now putting all of that together, we can then generate a regex that, thanks to the way that regexes work, can very, very quickly validate whether a given string, including the leftover question marks, could possibly validate to match the checksum that we're given. Now, if we have a look at this, this means that our process to take the input, which is the top line there, and process it all is fairly simple. We see a question mark. We try it with a full stop to begin with. And if that still validates the regex, we say, okay, cool. This branch of questioning is fine. Let's replace that question mark with the definitive full stop, add it to the list of things to check until we have no question marks left. And similarly here, we could try it with the hash and we say, hey, look, that's 4 hashes in a row. That's failed the checksum. So in this case, we don't bother checking any of the other question marks in that variant. We process through the list until we've either run out of question marks or run out of things to check. If we ever get a string that has absolutely no question marks left in it, we then say, okay, if that resolves, that's a fully definitive answer. We add it to our sum. Otherwise, we don't bother. We don't include it. And what this does is, look, essentially it's a very exhaustive search, but we have a little bit of what's called pruning here. And this means that, for this second example that you can see here, we don't bother checking all the other variants that start with 4 hashes because it's impossible for that to be true. So we are reducing the search space in some ways, but we are doing a lot of comparisons to ultimately get there. But let's have a look at the code, the way this version of part 1 was implemented. As I said, the code here is in an earlier commit in the repository below. This is prohibitively slow for part 2, but it would eventually get us to the right answer if we had unlimited time and we were happy to just leave things running. Alrighty, so we're using regex for this solution, so we import the regex package, and the only other thing we set up before we get into our main function is this pattern structure, which just stores the string and the checksum. In the main body of the day 12 function, as always, we read the input file into a string, and then we start to process it line by line. We know that each line is the pattern and then a space and then the checksum. So we split on a space character. We parse the checksum into a vector of unsized sizes. And then we keep the pattern as a string and we build up a list called patterns, which is all of our checksums. Now, after this, one line at a time from our original input file, we start to walk through each of the patterns from that original list. For each one of those, we dynamically generate the regex based on the checksum that we were given. I'll jump ahead slightly here to part 2. Part 2 requires us to repeat the pattern and the checksum 5 times over, which is why doing something like a full exhaustive tree search becomes prohibitively expensive because the number of leaf nodes and branches that we have to go through grows very, very rapidly when multiplying it by 5. But anyway, in part 1, we dynamically generate the regex that matches the checksum that we're given, and then we start to parse through each of the pattern's possibilities. So we start with a list of possibilities, which is just the original input file, and we search for the first question mark. If we do happen to find a question mark, we then start to generate variants about whether we replace that question mark with a full stop or whether we replace it with a hash. Now, we do a little bit of pre-work to work out where we are in the checksum. So if we know everything to the left of where we're currently looking has exhausted a certain number of hashes, for part 2, it's useful to do that because rather than store the pattern 5 times, we just start the pattern again. But we keep a counter of where we're up to in terms of how many pieces of the checksum we've gone through. We then do a quick check of how many question marks are left in order to finish whatever group we're currently in. So that means if we have 2 hashes to the left of where we are and we're up to a question mark and our checksum digit is 5, we try and replace the next 3 question marks in a row with a hash. And this is another bit of pruning in the search space, which means we don't bother checking those 3 hashes to be full stops as well, because if we do, they're not going to match the pattern. So we test that pattern. If it matches, if it's a valid match on the regex, we then add it to the list of patterns to check. If it's not, then we just do nothing with it and we just discard it and don't continue down this line of inquiry. So then the other option, the other branch, so you can see here the little bits checking if there are valid versions of the checksum with a hash and then with a dot. But if we didn't find any question marks, which is this none branch here, we instead say, okay, let's check the final string that we have. We put a dot at the end to make it a little bit easier to do the match. We check that against the regex. If it does match, we add 1 to the number of valid variants. And then we run through the rest of the lines in the list and ultimately get our answer for part 1, and we print it out at the end. So let's talk quickly about part 2. Part 2 is very similar. It's almost identical to part 1, but instead of just using the input file as it's written, we need to repeat the pattern and the checksum 5 times. This means that the solution that we just presented becomes way too slow. In the end, the search space that we have to go through, while being much, much bigger, becomes a barrier to running this regex check again and again and again. And even though regexes on modern computers are pretty quick, the checking of those long strings over and over again just means that it's not feasible to do it. There is a solution to this puzzle which looks at dynamic programming instead. And it starts to look at the answer from the right to the left rather than the left to the right. And by having known solutions to subsets of the puzzle, it saves us a whole bunch of computation. The current solution in the GitHub repository was the starting point of that. But as I said, I decided to move on to day 13. And while today's puzzle wasn't 2 stars, I hope in this shorter video looking through part 1, you still find something interesting, maybe a little bit into the regexes. But look, either way, I'm Elliot and I build stuff and I look forward to seeing you in the next one.